First up on stage, we have Catharina Geiselhart from PwC. And Catharina is a senior consultant in the energy and utilities team of PwC. Her focus is on the digital transformation of power and utility companies, with a particular interest for blockchain. She's the co-author of the study, The Developing Role of Blockchain in the Energy Sector, conducted in partnership with the World Energy Council. So, welcome up on stage, Catharina Geiselhart.
Thank you. Is this my clicker? Yeah. Well, first of all, thank you for inviting me and giving me the opportunity to speak a little bit about blockchain and its potential in the energy sector. To be very honest, at the very beginning, because I'm coming quite from the traditional energy sector, working at E.ON and companies like this, I wasn't really convinced at the beginning about blockchain and its potential for the energy sector. It took me a while, really deep diving in the regulation, in the technology itself, of course, and also looking at what roles could current actors in the market play in the future, until I was really able to say, okay, it is one of the enabling technology for a decentralized, but also democratized and more stable energy system. It took me a while because so far we cannot really talk about the digital infrastructure in the energy sector in 2018. And even when we talk about energy transition, it really continues to be analogous in lots of European countries. Maybe not in Sweden. And there are a lot of different trends today in the energy sector that are reshaping the face of the industry and also opening the way for a new business model. Internally, electric car vehicles that are setting energy suppliers and grid operators in front of new challenges, but also the fact that we have a growing amount of smart devices that we put into households, into industries, giving real-time information about consumption and production. The fact also that a lot of people decide to produce energy themselves and become what we call prosumers, private people producing their own electricity. Those trends, we can also see them a little bit more globally, because when we talk about energy, we do not only talk about a commodity that is being produced, traded, and distributed, but we talk about something else. We talk also about politics, we talk about infrastructure, we talk about economy, and we talk about people. People that really changed their behavior towards big utility companies, having other expectations towards services, having the will to become a little bit more independent towards those big companies. And also people that are willing to share their bikes, their cars, their homes, and also their energy. In the energy sector, we summarize those trends, might not be a rocket science for you, into what we call the 4 Ds. Decarbonization, decentralization, digitization, and democratization. And with that, we also understand the fact that we could enable people to sell and buy their electricity directly in a very secure and transparent way, and with a very high degree of independency. And that changes a lot of things, and it's exactly where blockchain started to make sense for the energy sector. Quite late, 2015, so I'm not a crypto billionaire, sadly, but still interesting. As I said, blockchain started to hit the energy sector in 2015, late 2015, beginning 2016, really by storm, and that from that moment on, one of the questions that we can ask all the time is if it's only a hype, or if it's really the starting point of the revolution, if it's going to put the whole energy sector on its head tomorrow. So 2 very balanced positions. And when we take a look at it a little bit deeply, we realize, of course, it's a highly regulated market. The market rules are really precisely defined, giving not much place for innovation. And also, we cannot really talk about it as a virtual good. It's a virtual good when you pay for your electricity bill, but it's still a good that needs to be physically produced and distributed. So it makes the implementation of a completely distributed system kind of tricky. And still, it appeared to be a very relevant and efficient technologies in lot of various applications, like in the Brooklyn microgrid, building a pool of saved electricity and supporting community energy models, bringing together operators of renewable energy assets and their neighbors willing to buy electricity locally, helping reduce congestion measure costs by integrating more renewable energies into the system. And there are a lot of other projects today that are still in the pilot project phase, in the proof of concept, but are letting us imagine an energy system where some of the main actors that we have today would play a completely different role. And to make sure we understand that market, at PwC we developed what we call a blockchain energy radar. We published our first study, blockchain and its potential for energy utilities, in 2015. And so we started to screen the market, every initiative that we found worldwide regarding blockchain and energy. And in the first year, we only found a handful of projects, mainly driven by startups and early stage companies. And only 2 years after, we already had a little bit more than 100, and I'm quite sure we do not have the overview anymore, projects that were related with a blockchain and energy consortium, partnership with startups and big companies, utility companies testing their first projects. And I will give a few examples. I will deep dive in some of them, not in all of them, but in some of them. And it's an interesting thing to see how much the partnership between startups and big companies are working very interestingly. But before I do so, I would like to ask actually the question, why is it so? Why is it so that there are so much companies today in the energy sector, not the most innovative industry, honestly, that are testing their first projects, partnering with startups, investing into dedicated teams. For a few days, I sat with someone working for a big oil and gas company, trying to sell a project, I must admit. And he said to me, well, no chance. We have a dedicated team of 15 people sitting in their office, working only on potential use cases for their company. How come is it so? Well, because the decentralized blockchain model let us imagine an energy system where some of the major actors in the energy system today, banks, traders, energy suppliers, metering companies, would not become completely redundant. At least we're not young enough to see that coming. And would play another role, a different role. A good example for this is the venture capital-backed startup, Conjoule, I don't know how they pronounce it in French, from Innogy, which is the ecological sister company from RWE in Germany. One of the first movers, they developed a decentralized exchange marketplace, energy exchange marketplace, enabling their prosumers to sell their surplus of electricity to some of their neighbors, consumers in the region. They have the choice among a supermarket, a school, a hospital, which they can provide with electricity. Today, that model is a little bit complicated in the energy sector because of only one aspect, the regulation. Today in Germany, if you're a prosumer, you have your own solar installation in the roof, and sometimes you produce more electricity than you consume. You can sell that surplus of electricity to the supplier that you still have to have a contract with. Or if you have a blockchain, a client-friendly platform, you can sell it to your neighbor. But you still need the utility company because you do not have the right as a private person to sell that electricity. You would have to do some regulatory steps where you would think life is too short. You need to register as an energy supply company. You need to conclude a supply contract that respects information and consumer rights. You need to name a balance group operator. You need to report load flows to the grid operator, and you need to sell at fixed price, and so on and so forth. So definitely, it's not made for a private person. What utility companies do today, and that's the case of Innogy, is they take the role of a service provider. They say, we develop a decentralized business model for you, enabling you to sell the electricity to your friends or neighbors, and we take in charge of all that energy jungle book that no one has to deal with. So you'd say, okay, it's not really a distributed system, and it's true, it's not a distributed system, but still, even 2 years after the technology hit the energy sector, we found big companies that are completely redefining their business model, repositioning themselves in the market, developing new services, and kind of closing the last mile to the end customer, which is quite new. Another company that is testing this is the TenneT. TenneT is a transmission system operator, so for those who might not be energy freaks, transmission system operator, a TSO, they are responsible for the stability of the grid. They're responsible to maintain security of supply. It's a highly regulated business, it's super complicated, and it's also very technical. If you ask someone working at a TSO what they do, he would say, basically, we keep the lights on, which is a little bit shortened. They try to look cool, probably, and it's not entirely wrong. Today, they face a lot of challenges because we have a growing share of renewable electricity in the system and the overall supply. The grid tends to become more volatile. So it often comes to what we call transmission bottlenecks, and to manage those transmission bottlenecks, a TSO, like the TenneT or other TSOs, have to engage in what we call congestion measures. Firing up conventional power plants in the south of Germany, for example, or wind power curtailment. And those congestion measures, they cost last year 800 million euros to Germany. So they need to find new ways to maintain the security of supply. And this is one thing that they did in partnership with Sonnen. Sonnen is a solar energy storage company. They set up a pool of decentralized batteries for the TenneT, and when and where required, they absorb and discharge excess power in a matter of seconds. The energy flows, the electricity flows among the various regions that they have, that they include, is managed by Hyperledger Fabric, the technology used by IBM. We can argue on how decentralized and how distributed a private technology might be. In that case, because the TSO has a highly regulated market, and I think they have some troubles using personal data, we can understand that they feel more comfortable using a private technology. Another project I wanted to tell you about is what we are running at PwC with the very German Technische Werke Ludwigshafen, let's say TWL. What we are experiencing is to create an auto-balancing microgrid that would be independent from the higher grid level. Our microgrid is a set of B2C prosumers, B2B consumers, a storage station, and local solar power producer. Actually, this is a balancing group, and to balance that balancing group, we use blockchain. We use actually smart contracts. We have a bunch of IoT devices in that microgrid that give us real-time information about consumption and about production. Send it to a few light nodes. The light nodes communicate to one full node and write it directly, all the transactions in the blockchain, helping the smart contract to match supply and demand in that microgrid. It's very early stage. We installed the IoT devices for a couple of, not even a week, and we're now testing the technology. The technology that we use is the one developed by the Energy Web Foundation, the Tobalaba. I don't know if you've heard of it, but it's a version from Ethereum, and it's a proof of authority. The blocks are validated every 3 to 4 seconds, so it's kind of more scalable than another technology by now. So I've gave an example about peer-to-peer energy trading, about grid stabilization, about an auto-balancing microgrid. I'd like also to give a bird-eyes view at what else we can do with blockchain in the energy sector. This is Spectral is is a quite new startup that I really admire for their vision of the energy system, of the future energy system. And they recently launched an energy token in partnership with Alianda, which is also a TSO. Today, in the energy sector, you will probably know this, energy suppliers are taking information, consumption information out of smart or not smart meters. They are generating an electricity bill, and then the transaction, the monetary transaction, is done from a bank to another bank. No rocket science. In that case, it's a little bit different. In that case, if you look at that picture, it's the community of Deuceval in Amsterdam. There are 16 office buildings, 1 greenhouse, a restaurant, a cafe. Want to go on holiday? And they are all connected to one private smart, behind-the-meter smart grid, which enables them to exchange the electricity that they produce with the solar panels. And to pay for that electricity, they use the Juliet token, probably Juliet because of the jewel, I think. So that means that the monetary transaction is not done from a bank to another bank, but from a virtual currency wallet to another virtual currency wallet, bypassing one big central entity. And also, for now, it's only a peer-to-peer exchange of electricity with an energy token. But they could use that token to trade for goods at the Deuceval Café, for example, or integrate other community services like a car-sharing program. They could build a sustainable, resource-based, local circular economy. And that gives a different purpose to what we can do with blockchain in the energy sector. So because we know that there are so much different application of blockchain in the energy sector, we developed a structured process, how we can help, how we operate. We know that there are a lot of different challenges. And because we're here to build things, well, when we build things like we do on the electricity project with the TWL, we realize there are so much expertise that we need to have when it comes to the regulatory aspect, when it comes to business model building, when it comes to the financial aspects too, of course. And because we wanted to go a little bit further, we invested into a dedicated team of programmers, men and women, who are building complex systems, so a bunch also of smart contract coder. So we might be consultants, but we do not only bring the solution on beautiful slides, but on real programs. So to those who might be still a little bit, let's say, skeptical about blockchain, although I don't think there's a lot of you here, I would like to know if you remember the first version of Amazon and the first version even of Facebook. It changed a little bit, I think. So to the question if blockchain only is a hype, I always say, of course not, it's not. It's actually going to be a completely accepted underpinning standard, like the TCP/IP standard 20 years ago. When we build things with blockchain, something I wanted to say also, when we work in European countries, in developed countries, we reduce cost, we manage data securely, we build processes more efficiently, we solve the business need, which is okay. But when we think about blockchain in developing countries, what we could do with blockchain energy in a country where energy costs sometimes over 40% of the costs of one household, if we bring energy at lower price locally, we could actually make other things possible, like enabling parents to send also their girls to school. That also gives us another overview of what we can do with technology. So I think I'd like to say about blockchain that it's the infrastructure of tomorrow's exchange of value and information. And the question is not, what can we do with blockchain? What are the use cases? But more, how do I want to see the change in our societies? Thank you.